Okay, so we're going to get rolling again. It's cut the break a little bit shorter today, so it's 10 minutes. Usually it'll be more like 15 minutes. The breaks are good times if you have questions or you didn't understand. We can chat about them and whatever. Like I said, it's a good time to go get food and that sort of thing if you have it in your car and what have you. The first day of class is always a little weird because, you know, most people just go through the syllabus and then you move on and whatever. The problem is in this class, I only see you once a week, so there's not another class on Thursday for us to get started. So we have to start tonight, and we don't really have a choice. So I recognize that you've never seen the book, you haven't gone through this, but we're going to go through the first chapter. So you can read it when you have time. It's a lot of kind of basics about building and that sort of thing. It's not particularly exciting, so I'll warn you ahead of time, but hey, you've got to get through it somehow, right?
You still want to score you want.
Ideally, you know. Ideally. Like I said, the stuff that I care the most about is the stuff that's going to show up on the slides, right? So, chapter 1 is called Making Buildings, okay? So, from the title, you could kind of understand that it's kind of the basics. Okay, so let's start with a quote. Go into the field where you can see the machines and methods at work, right, that make the modern buildings, or stay in construction direct and simple until you can work naturally into building design from the nature of construction. Right? So this is Frank Lloyd Wright in 1931. Interesting how he's focusing on the importance of construction rather than design. Right? And the fact that you really need to understand construction to be good at design. Okay? This is focused on the architecture crowd, right? This is why this kind of stuff is really, really important, because that's how you become a good designer. Okay? So let's talk a little bit. We bounce around a little bit in chapter 1. But one of the big themes that will continue to go through this book that you'll notice is the theme of sustainability. Okay? So let's start with a few statistics. Okay? Buildings account for 30 to 40% of the world's energy use. The buildings account for that. That's a pretty high percentage, right? Construction and the operation of buildings accounts for 1/3 of this country's total energy use. 2/3 of its electricity is in buildings. Okay? Construction and operation also account for half of the country's greenhouse gas emissions. So we get all up in arms over our cars, right, and what they're doing to our environment. And so very rarely do we actually consider that the buildings are doing half the damage. Right? So that's why the theme of sustainability ends up, right, becoming important in this sort of a class. And it'll be something that we'll touch back and forth on as we go through the semester and talk about these materials, right, and why they might be good or why they might be bad. So, does anybody want to take a stab at defining sustainability? Yeah.
Something that would not be replaced or used on.
Okay, sure. I like that. Anything else? Okay. What else? Exactly. Very good. Use and reuse. Anything else anybody else wants to add? No? Okay. So the technical definition, right, is meeting the needs of the present generation without compromising the ability of future generations, right, to meet their needs. Okay? So this is kind of the boilerplate example here. But the big thing is that we're not depleting the resources that somebody else might get to use in the future. Right? So we're trying to be neutral, right? We talk about being carbon neutral. We drive hybrid cars. We do all this kind of stuff. We talk about being green, right? It's the buzzword right now. We're going to try to go away from thinking sustainability, right, in this class as I get to drive my Prius, right? And we're going to talk more about, right, what do these building materials mean, right? How long do they last, right? Can they be reused, right? Those kinds of bigger issues. Right? So, give me some ideas of what we might do to increase sustainability in building practices. You already touched on the ability to reuse a material. That's good. What else? Yeah. Okay. Local supply. The cost of transporting a particular material. Right? That's great. What else? Yeah, something that easily can be replaced. Right, exactly. Any other ideas? No? You guys are all quiet today. It's okay. Okay, so how about if we use solar or wind energy, right? It's a renewable source of energy, so we're not depleting, right, natural resources. It's something that we can use over. What about if we use solar to heat the building, so we're not using any energy at all, right? It's direct thermal transfer into the building. So maybe if we're in the desert, right, we use diurnal cycles, day and night cycles, right? The sun beats on the big thick wall during the day, right? Radiates the heat to the building at night when it gets cold outside, right? Those kinds of things. Can we use those abilities? How can we naturally heat and cool, right? Just providing an operable window in a building can make the difference from having to run the air conditioner or having somebody be comfortable just because they can open the window outside, right? Those kinds of things can make a big difference. What about reusing an existing building rather than tearing it down? Okay? You know the average life of a track house right now is less than 30 years before it gets torn down. It's kind of scary, right? We used to build, and I live in an old ranch house, right? It was built well, right? It's built to last, right? Track houses are built for 30 years. They're built to sell, right? And then they get torn down or substantially remodeled, right? And sold again, right? It's a money-making thing rather than something that's sustainable long-term, right? If you go into San Francisco, right, and you live in one of those Victorians, it's much older still, right? If you go back east, right, you can live in a house that's 300 years old, right? Heck, if you go abroad, you can live in a house that's 1,000 years old, right? So what can we do to reuse a building rather than tear it down and build a new one? Okay? Like you said, bamboo. Okay, we can use wood from sustainable forests. Okay, forests that have been managed, right, so that they're not depleting resources, they're not killing off habitat, those kinds of things. We can also reduce various forms of pollution, right, from the processes of making the building materials themselves, and this is a big problem, right? And we'll debate as we go along things like steel as being a sustainable resource or a sustainable material, right? Technically, right, we can use the steel out of a building, melt it down, make new steel, and build a new building. So does that make it a sustainable material just because we can reuse it? Or does the cost of making it new steel in the energy that it takes to do it make it not sustainable? Right? It's kind of an iffy thing that we'll talk about. Yeah.
I thought concrete was extremely intensive, labor intensive and materials intensive.
Mm-hmm.
It's just that it lasts for so long, but
Right.
it's like the highest.
It is. But there are things that we're trying to do and additives that we're trying to add that change that. Okay? So we use the additive fly ash, for example, in this discussion. And again, if we go a little off topic, it's not the end of the world. And if you have no idea what fly ash is, that's perfectly fine. We'll cover that eventually, right? But what happens with something like fly ash is it's a byproduct of a coal-fired power plant. Okay, it's the ash out of the chimney of one of these the electricity plants, right? They take it, and lo and behold, they can use that as a direct substitution for the cement, right? That is the big cost in energy, right, and pollution in concrete. We can substitute the cement out and put the fly ash in, right, in some percentage, and, oh my God, it makes the concrete stronger than the cement, right? So we're getting benefits out of the concrete, but we're also using something that's a sustainable material, right, or a byproduct of another material. So there are these little ways that we can make a difference, right, and we're going to talk about what those differences are. The other example is you tear down a concrete building, you grind it up, and you use it as base rock somewhere else, right? So there are ways to get around it, but that's what we're going to talk about in relation to sustainability in these materials. Do you guys have anything else to add? No? Okay. Okay, so let's talk about sustainability in the life of a building. Okay? So the origin and manufacturers of the materials in the beginning, right? Is the source of the materials renewable or non-renewable? Okay? Is the wood coming from a sustainable forest? All right? Or is it coming from a forest that practices clear cutting? Right? Is the material a recycled material to begin with? Right? And I'm not out here spouting that we should all use plastic bottles to make our houses, right? We're being somewhat realistic, right? We're talking about the big materials and how can we make somewhat of a difference, right, without being too extreme. The other thing about it is how much embodied energy is in the material, okay? And this is the amount of energy that's used to get the material from wherever it was made to the site, Okay, and that can be pretty costly. Okay, the example here that I'll go off on some tangent, it's not particularly a building material, but you guys have all been in the store and you've seen bottled water, right? You guys seen the bottled water that's Fiji water, right? It's kind of the square bottle or whatever, okay? It costs more to ship that from Fiji to here, right, than if we just, that's the big cost, right? The bottle of water doesn't cost much at all, right? We pay $2, but 98% of the $2 that we spend for it are not for the water, they're for the transportation from Fiji to here, right, so that we can drink the water, okay? So that transportation cost is the kind of thing that I'm talking about here, okay? So, and also what pollutants are discharged into the environment for the process, right? You make cement, and guess what? You're going to discharge a lot of bad materials. So in terms of construction of the building, how much energy is used to transport the materials to the site? How much energy and water, right, are put to use on the site for the building, right? When we talk about doing slurry walls and that sort of thing, right, the cost to the environment, what about dewatering and excavation? All those things are big problems, okay? And what pollutants are associated with the installation of this material, right? I might also add, what about the pollutants that are naturally in the soil that you might unearth, okay? So you guys all familiar with Alameda? Anybody live in Alameda? Oh, good, I can pick on Alameda. That's good. Right? I'll pick on it throughout the semester a little bit. Okay? So Alameda, right, we have that Naval Air Station out at the end. Great view of San Francisco, right? Beautiful area, right? The problem is, right, the ground is so toxic, right, that you can't do any excavation. They won't let you do any. Right? So this is the kind of thing we're talking about. You can't build anything there, right, because the ground is too toxic to disturb. Yeah.
It's really acidic, isn't it?
Yeah. Yeah. Super bad. Okay? And so we don't want to excavate, right? Or if somebody was going to, let's say, plan a development, which of course somebody is eventually going to plan a development, they're going to have to do so much environmental mitigation to cover up all the stuff that they cause, right, that it's going to be so costly to do it. But that's the kind of stuff we're talking about, right? We have problems. Okay? The other thing that people often forget about buildings is there is an ongoing cost to the building beyond just the electricity to run the lights and that sort of thing, but it's all the maintenance. Okay? If you guys have been out here, and some of you, this is the first time you've been here, right? But if we walk around in a rainstorm, you notice that little canopy over the walkway, there's about 10 different leaks that leak through, right? That's all deferred maintenance that somebody has to pay for and somebody has to fix. And if they don't fix it, it's long-term going to cause problems. So there are always going to be these kinds of maintenance issues, these kinds of ongoing costs, right, associated with the building. The other thing is about problems of indoor air quality, okay? Are there weird off-gassings that are happening in the building that we should be concerned about, okay? You guys all, you get a brand new car, right? You keep the windows up because it smells so good because it's the new car, right? You guys have all done that? No? Oh, my wife totally did, right? Her car, windows up the whole time, still smells new, right? That's all this off-gassing stuff that we probably shouldn't be breathing, right? But that affects the life of the building, right? So the other thing, how much maintenance, etc. Okay, so the end of the building life cycle, right? How are we able to demolish the building, right? Number one, can we extend the life of the building so we don't have to demolish it in the first place? Okay. Number two, if we have to demolish the building, can we recycle any pieces of the building, right? And you'd be surprised in this day and age how much of this is actually recycled and reused, okay? From the local scale, I'm tearing out my kitchen. I put my kitchen cabinets on Craigslist and somebody buys them, right? Or takes them for free because they want new cabinets, right? It could be something that simple to something like this, right, where they're actually going to grind up all that steel and reuse it, right? Because it's too valuable in this day and age, right? So, recycling the building itself. Okay. So, any questions about sustainability so far? No, kind of the overview sort of thing. We'll cover it more as we go along. So let's talk about the work of the design professional. Okay, and we're just going to try to establish some bounds based on construction and architecture and where that works. Okay, so let's say I own a piece of property. Okay, I have to have some desire or idea that I want to build something new on it. Okay, so it could be I want to build a house. right? I own a vacant piece of property. I want to build a house. It could be that I want to build a shopping mall. It could be a lot of different things, right? So you have to start with somebody who owns the property and then wants to do something, okay? The owner is then going to engage some kind of a design professional, okay? It could be an architect, could be an engineer, right? It could be a professional company that determines what's the best use of a particular land, right? There are companies like this. I have a good friend who works for one, right? That somebody just comes and says, "What should I do with this land?" Right? And they go through an analysis and say, "Oh, you really need to have a shopping center on this land because there's so many miles from the nearest shopping center, blah, 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 blah." Right? There are companies that do this, right? But let's focus a little bit down into the architect realm, okay? And they're going to develop some kind of a plan, right, for the building. And it's going to start with an overall plan, right? I want to build a library on this particular building. I want to build a house, right, that sort of thing. And they're going to progressively get finer and finer levels of detail for this particular project, right? And after approval by a local planning agency, right, this often results in some kind of construction documents that can then get sent to a contractor. Okay, usually the owner will engage the contractor, and the contractor will build whatever it is that the architect has designed. Okay, so this is the normal flow of things. Let's see if we can go forward. Okay, so the thing about it is it's the design professional's job to sort through all of these construction materials, all of the various options that are out there, right, and address the needs of the client, both in budget, right, and in actual what the building looks and feels like, right, to also address whatever planning authority, right, restrictions might be on the site. Right? They're going to work through all that stuff and come up with some kind of a reasonable solution. Okay? So my intent in this course is to familiarize you with all of these materials so that you, right, could make this kind of a decision. Okay? If you have knowledge of the materials, you can then at least help someone else make or make these kinds of decisions. Okay? And that's the idea. So, a zoning ordinance. Does anybody know what a zoning ordinance is? Yeah. Exactly. So a zoning ordinance is something that the city sets up, right? I use the city loosely, right? Could be a county, right? That determines what type of building can be placed on a particular piece of land. Okay? So the city's going to give some guides, and this is going to help shape, right, what the overall city looks like. It's control, right, by a particular city that encourages development of a certain type in a certain area, right, and development of a different type in a different area. Okay? It tends to restrict how much land can be covered, right? So if I have a lot that's 10,000 square feet, how much of that lot can I cover up with a building? Okay? How much open space should there be? That sort of thing. Okay? It determines how far a building can be from its adjacent property line. Okay? So if we look in the San Francisco Victorians, right, there is no setback. You can build right up next to your neighbor, right? If you live out here in the suburbs somewhere, there's probably a 10, 15, 20-foot setback from the side property. So you can't build right next to your neighbor, right? And so this controls the density, right? The density in San Francisco is much higher than it would be out in the suburbs, right? And so that's going to change based on this kind of a zoning ordinance. It also determines how tall a particular building can be, right? What's the maximum height? Can I go 3 stories? Can I go 4 stories? That sort of thing. Okay? So, the interesting thing is not everywhere has a zoning ordinance. It is by far the most common. But if we go down to Houston, Texas, okay, Houston has absolutely no zoning ordinances. So if you own a piece of land, you can build a skyscraper on it, or you can build a single-family house on it, right? And so it's very interesting, and it's used very commonly, right, in the architectural thesis realm, right, as a case study for understanding how natural building would work. Yeah.
Why is that?
It's the decision that they decided to make. Okay, and it's to give, maybe it's because it's has a certain political affiliation in that area. They believe more strongly in property rights, right, and that you could build whatever you want. Maybe it was just because they started doing it that way in the 60s or whatever, and it's just kind of lived on, and nobody wants to change it, that sort of thing. But it is a very interesting case study because you have a lot of diversity that you don't get in other cities. Other cities tend to be very planned. We have a downtown core that has a certain amount of commercial. Maybe it has commercial with residential above, right? And then as we extend out, we have more and more residential, that sort of thing, right? And so the nice thing about Houston is you have a very different diversity, right, of how this works. And lo and behold, even though you have this flexibility, there still are neighborhoods. It's very rare to have, the single-family house next to the skyscraper, right? The skyscrapers tend to come together anyway, right? So it's a very interesting case study. But I throw it out there not because it's that relevant to you, but it helps illustrate the concept of zoning ordinances. Okay? So let's move on to building codes. Okay? What is a building code and why is it necessary? Nothing? No question? No? Yeah? Yes.
So it's going to have a baseline for the structure of a house at the same
Sounds good.
Need requirements set by the city or county.
Okay? I like it. I like it.
Well, I was thinking safety. The biggest
Keyword.
reason is safety.
Safety. Safety. So, if you were up here, would you be a little wigged out? Maybe? What about if there was an earthquake? That freaked me out a little bit, right? So, the idea of building codes, and the reason that I associate this picture with it, right, is because they have to do primarily with public health and safety. Okay? So, they're going to set minimum standards, and you guys were getting at these, for construction quality, right? The minimum standards that you have to achieve, right, to have a building that's safe. The structural integrity of the building. Is it built so that it can withstand the types of things that will happen, right? In here, is the building built so that it will withstand an earthquake, right? If you're back east, right, will it withstand a hurricane, right? If you're in the Midwest, right, will it withstand a tornado? Those kinds of things, right? Basic structural durability and livability are a little bit harder to define. There are usually certain standards that we meet. An example of livability, right, would be if we talked about the minimum distance for an electrical outlet in a kitchen. Anybody an electrical contractor here? Okay. So we've got certain requirements. You have a kitchen sink, and within 2 feet of that, you have to have an electrical outlet. Correct me if I'm wrong, right? And then if you have a wall that has no sink, right, it's every 4 feet. You have to have an electrical outlet. So that's what we're talking about livability, right? Do you have a plug that's close enough to where you need to be, right? The fact that the plug has a GFI when it's next to the sink so you can't electrocute yourself, that has to do with just general safety. I'm looking at this list and it's like, no, that's just, you be safe, right? We're also going to talk a little bit about accessibility, right? Are you able to get in the building? What are the minimum sizes of the doors and that sort of thing? And fire safety, right? Is the building going to be safe in a fire, right? So the International Building Code, the IBC, right, is a model building code, okay, that cities or towns, right, or counties can adopt, right, and or modify to suit their own needs, right? But it's an overarching building code that is trying very hard, right, to be a building code that works internationally, so that there are certain minimum safety standards across the globe. Does that make sense? Right? It used to be that we in the U.S. had stricter standards than other places, right? And the reason that we have stuff like this is because we're trying to extend those standards so that everybody is safe. Okay? This is published by a private nonprofit organization. So this is not a government entity, right? They're trying to be outside of the government so they can be more objective. Okay? So, within the International Building Code, we have what are called occupancy groups. Okay? And this is a good place to take a little interlude and talk about the types of things I would ask on a test. Okay? I would never ask, right, please tell me what an A2 occupancy group is. Right? That's far too specific. Okay? Would I ask something about what is the purpose of an occupancy group? Yeah. Right? But I wouldn't be that specific, right? I wouldn't say, what is a type M occupancy group? Right? So we're talking about bigger questions. Does that make sense? Okay? But the point is we have some of these. So A1 to A5 are big public places. B is a business, right? And so we can glean certain things from these types of occupancy groups. If it's a business, right, there's going to be people there during the day, not at night. Right? If it's a big public assembly place, There's going to be big groups of people there at certain times, and it's going to be completely empty at other times, right? If it's educational, right? We're in an educational type setting here. Mercantile is like a store, right? And then we have R1 through R4, which are residential occupancy groups. It means somebody's going to be there at night sleeping, right? And so these occupancy groups, right, are primarily there, right, to distinguish various needs for safety. Okay? So, if I had an occupancy group, right, for a hospital, right, it's very different than if I had an occupancy group for my own house. Right? Does that make sense? Right? So we want to have certain standards that apply to a hospital and different standards that apply to my house. Right? And it's an easy way of distinguishing between them. Okay? So, beyond groups, we have International Building Code types. Okay? So within a group, certain types are allowed. Okay? So, the types, right, are specifically to deal with the amount of fire resistance of that particular type of construction. Okay? So, okay, type 1 is made from highly fire resistant, non-combustible materials. So a type 1 example might be a concrete building. Okay? It's very fire resistant. So, if you were building a hospital, right, or a fire station, right, or something that should survive almost anything, you would be looking at a type 1. Right? If you're building a single-family house with one family living in it, you can move all the way down to type 5, okay, which is built of combustible material, so it's wood framing, okay, that can burn, okay, but we're going to do some fireproofing, right, so that it's not unreasonable enough so that you could get out, okay? So the point is the types just distinguish the amount of fire resistance of that particular building. Does that make sense? Yeah? Okay. So, again, I'm not going to ask you for these kinds of information, but I put these up there just because if you really needed to know what a particular type entailed, you can always look it up. Right? You don't have to memorize it, just look it up. These are out of your book. Right? Page 10 out of the book. Right? So you can look it up and find out. So then we also have construction standards. And construction standards have to do with the quality, right, or the baseline of a particular material. So that if we talk about cement, cement is cement is cement, no matter who you buy it from, right? So, this ASTM International, okay, which formerly was the American Society for Testing of Materials, right? You've probably seen this logo on various products down the road. Establishes specifications for a particular material, right, and a method of construction. So, ASTM C150 refers to Portland cement, right? So, if you go to Home Depot and you buy Portland cement, it has to conform to this particular standard. Right? So you know that cement that you bought at Home Depot is the same as the cement, even though it's a different brand that you bought at Lowe's. Does that make sense? Right? So we have these certain standards so that we have a certain reliability and a certain expectation that a material is going to perform in a certain way. Okay? And this also allows for some abbreviations, right? So we can refer to, instead of Portland cement, right, we can refer to ASTM C150, and we know exactly what's allowed or what's not allowed. Okay? So there's also ANSI, which is the American National Standards Institute, and it's a little bit different, okay? But it develops and certifies North American standards for a broad range of products, including windows and mechanical components, right? Things that people buy. Does that make sense? So it's like, I bought a window, it should meet certain standards for a window. Does that make sense? I bought a furnace, it should meet certain standards for a furnace, that sort of thing. Okay? Okay, so let's talk a little bit about constructing buildings. Okay, so we started with the role of the architect, the owner, right? Then the architect comes in and designs a particular building based on all these various information that we talked about, the building codes, the zoning ordinances, the IBC types, right? That sort of thing, the group and the type. Then we move into constructing the building. And there's a variety of ways of going about constructing a building, some of which are more standard and some of which are a little bit different. Okay? So we have what's called the design, bid, build mode of construction. Okay? So this is typical construction for a residential house. Okay? It's design first, followed by construction. Okay? So this little chart, this flow chart, says that here's the owner, I own the land. Okay? I go out and I hire an architect and an engineer. They design the building. And then I go out and I hire a general contractor, and the general contractor builds the building for me. Okay? Does that make sense? Okay? That's typical. So the other type here is called design build construction. Okay? And this is what I would consider myself falling under. Okay? So I have a degree in architecture, so I can do the design work, and I also have a contractor's license, so I can actually build the building. Okay? So the owner, instead of hiring an architect or an engineer and then going out and hiring a contractor, hires one person who can do both. Okay? And so this is a very different way of looking at the construction process. Generally, the design and the construction are very integrated. And it results in unique, highly custom sort of results because things can change as they develop. Right? It's much less strict. It's not, here's the final product, I build exactly this product. It's, wow, I didn't see this coming, but now we have an opportunity to do this. And so we're just going to change it on the fly, right, and do something different. So it's very different, and it takes a little bit of getting used to. It tends to be a little bit more expensive. Let's be real about it. Okay? But it also requires less planning ahead, right? Less I have a complete package, and more let's just get started building something. Okay? So it's a little bit different way of going about it. Okay, so as we move forward, this is called construction management at a fee. Okay? So the owner out here goes out and hires the architect and the engineer, and they design the building. Then the owner goes out and hires a construction manager. Right? This is because they don't want to deal with the construction process, or maybe it's a large company that owns the land, and they don't want to be actively involved. They go out and they hire a construction manager, right? And then the construction manager goes out and hires the actual contractors. Does that make sense? Or excuse me, in this example, the owner hires the contractors, but pays the manager to manage the contractor. Okay? The owner is not directly responsible for the work itself. Right? That's what the manager's for. That's why they're paying the manager. Okay? Construction management at risk, right, is what I started to say the other one was, and I apologize. The owner goes out, hires the engineers and the architects to design the building. Then the owner goes out, hires a construction manager, and then the construction manager goes out and hires the people that actually do the building. Okay? And the reason that this is at risk is because the construction manager says, I can build the building for this. Right? And they're then held to it. They're responsible for making the budgets, making the building built on time. Does that make sense? Okay. So a little bit about scheduling. Okay? We can perform sequential construction. Right? This would be if you were building a house sort of thing. Generally, you do the design first. Right? Then you'd bid it. So you'd send that design package out to a contractor. They'd bid it and let you know this is how much it's going to cost. And then you would start construction and your house would finish. Right? It's sequential, one after the other. The advantage of phased construction, right, and this is for bigger buildings, is you might start with design, right? You design the foundations first, right? Then you design the shell and the core, and then you design the interiors, right? Bidding starts, right, phase. So you finish the design of the foundation. Bidding on the foundation starts next, right? As we move down here, guess what? As soon as the bidding's done, they start the construction. Does that make sense? Right? So things overlap a bit more, and the building gets built faster. This works primarily in much larger construction. Right? You're building the AAA building, you're building an office building, that sort of thing. You're going to want to be in the phased construction realm, because otherwise it would take way too long. Okay? If it's smaller scale, it's going to tend to be the first option. Good question? No? Okay. All right. So team collaboration. Okay? This is part of the reason that I like this class so much, is that we have people that are in the construction industry, and we have people that are in the architecture industry, or trying to become people that are in the architecture industry, and vice versa. And part of the advantage of something like this is hopefully by the end of this class, you will see what the other person is doing, right? And you'll understand their involvement and why, right? There's always this joke about the architect doesn't really know how to build a building, and the contractor has to, fix all the architect's mistakes, right? If you understand construction well as an architect, the contractor will be really happy, right? If you, as the architect, understand the value of the contractor and the fact that they know how to build the building, right, and you involve them, you can end up with a far better product out the door. Okay? So I invite you in this class to start to collaborate and start to understand what the construction side brings and what the architecture side brings, right, to the table. So the more participation you have of the actual person who's going to build the building, the better the design is going to be. Okay? Which is part of the advantage of a design-build operation. Okay? So overlapping of the design and construction phases reduces the time to market. That's what we saw in that last phase construction example. Okay. So that's it for today. I've got you out a little bit early, which is always good. Okay. We're going to read. Can I borrow your book for just a second? Sorry, I didn't read it out. Just want to make sure I get it all right. We are going to read chapter 2, which is Foundations. It starts on page 29 and ends on or about page 84. Okay? So I know these are long, right? Recognize, remember, every time I show you these, I'm just picking pages at random, right? Whole page of pictures. Right? So it seems like a lot more reading than it really is. Okay? The other thing about this, okay, so we're in here, right, in the activation side. Notice again, random page, right? Lots of pictures. Don't freak out. When we get to the end of the chapter, almost there, okay? Right here, key terms and concepts. Okay, I know this list is really, really long. Okay, don't stress out about it. But take a glance through this list and see, am I kind of understanding what these generally are? Okay? And I know that this is the first time. I'm not going to give you a pop quiz, right? But it's a good example of doing the reading ahead of time and kind of understanding what it is that I would expect you to kind of have an idea of. Does that make sense? Okay? So, we've got that. I won't ask you to do the review questions, right? But if you want to do the review questions for extra review, that's fine. I think the most valuable thing are these key terms and concepts. Okay? There is a glossary all the way in the back of the book, so if you don't understand what a particular term is, flip to the glossary and you can understand it. Make sense? Okay? Look at the pictures. That would be the other thing, because you can learn an awful lot just from the pictures. Right? And you'll see in the slides that I take pictures out of the reading and talk about those particular pictures. Right? So, for example, we'll get down here. Let's see. 29. Yeah, that was page 10 for those charts. Right? So, in this particular example, right, we talk about caisson, socketed caisson, and whatever. All that doesn't make any sense to you yet. It's okay. Don't worry about it. We'll talk about it next week. Right? This particular example is a picture, and it's very illustrative of everything that the text is talking about. Right? So a lot of times we'll try to associate those kinds of things together. Okay? So we'll get better. Don't worry. You'll learn what to look for in the reading. Okay? What? No sketch today. No sketch today. We'll start with the sketches. I promise next class. Not everybody has it anyway. So a little bit about the class in terms of where we're going. Okay, I don't if you're thinking, oh good, I'm going to read ahead because I've got extra time this weekend. I don't do the book in order. Okay, so we do chapter 2, and then we skip to chapter 13, 14, and 15. Okay, so we move from foundations to concrete. Somehow it seems like a much better organization to me to move from foundations to concrete. So we'll do 13, 14, 15, then we'll go back and do 8 and 9, followed by 10 and 11, and then we'll go back to the beginning and start with 3. Okay, so it just jumps out of order a little bit. I will have a calendar up on the website probably tomorrow, so you can look ahead. Okay? Are there any global questions before you leave? Yes. 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 I will try very hard to get the notes up tomorrow for next class. If I don't have them up, then they'll still be up probably on Monday at the latest. Okay? I will also try to put the video up as quickly as I can. Usually, my schedule works pretty well, so I should be able to have everything up tomorrow. That should be the plan. Okay? Any other questions before you go? Yes, sir.
Have that book by next time?
Ideally, have the book by next time. Like I said, I'm not going to quiz you next time, so you're off the hook in case you don't have the book yet. But now would be the time to go order it on Amazon and have it come to you. By the way, if you're a student and you're registered at DVC, you have a weird email address that ends in edu, which makes you eligible for a free year of Amazon Prime, which is 2-day shipping.
Is it still free? I thought it was now half price for students.
No, it's free.
Is it?
I don't know, maybe not. Maybe it's half price.
It's free.
Is it free? Yeah. So anyway, if I float that out there. You all have a new email address. You can get the book in 2 days if you really want. Okay. None of the tests or quizzes will be open book. If you want to download the calendar, the course calendar that will say which reading is assigned when the assignments are, whatever, you can subscribe to that link in your calendar. I can show you how to do it like tomorrow on midnight. The tutorial for how to do it is in the